Every plumber I've ever talked to says the same thing when you ask them privately. They've never once used a bottle of Drano in their own home. Not once. And when you press them on why, they get this look. Not quite a smile, not quite a grimace. More like the expression of someone who knows exactly how a magic trick works and can't quite believe the audience still falls for it. That bottle under your sink? The one with the bold lettering and the promise of a cleared drain in 30 minutes? They won't touch it. The person whose entire profession is keeping pipes healthy, the person you call when something goes seriously wrong, has made a deliberate decision to keep that product out of their own plumbing. That's worth sitting with for a second. I spent the better part of 3 months pulling on this thread, talking to working plumbers, retired plumbers, a couple of pipe material engineers who were surprisingly willing to get candid once I explained what I was looking for. I went through safety data sheets, old trade publications, a handful of studies that never made it into mainstream coverage, and what I found wasn't a dramatic conspiracy. It was something almost more frustrating than that. It was just a straightforward story about what happens when a cheap product gets marketed brilliantly, becomes a household habit, and then quietly keeps costing people money in ways that never get traced back to the source. The drain cleaner industry does about $3 billion a year in the United States alone. Think about that number. $3 billion annually for a product that the people who understand plumbing the most refuse to use. There's a gap there, a real one. And the gap is worth understanding because once you see it, you'll never look at that bottle the same way. The active ingredient in almost every chemical drain cleaner on the market is sodium hydroxide, lye. And what it does to organic material, it also does slowly and reliably to your plumbing. This is not a fringe claim. This is in the chemical safety documentation. Sodium hydroxide works by generating heat through a chemical reaction, sometimes reaching temperatures above 200 degrees Fahrenheit inside your drain, while simultaneously breaking down the clog material through saponification, which is essentially a forced chemical conversion of fats and proteins into a water-soluble form. That sounds efficient. And on the clog itself, it often is. Here's the problem. Your pipe doesn't know the difference between the clog and itself. Older homes, anything built before the mid-1980s, frequently have steel pipes, cast iron, or in some cases older PVC formulations that weren't designed with this kind of repeated chemical exposure in mind. The heat, cycling alone, that sudden spike to extreme temperatures in a pipe that might be 40 or 50 years old, causes microfractures over time, not visible to you, not detectable without a camera inspection, but cumulative. Every time you pour that liquid down the drain and it gets to work, you're shortening the functional lifespan of the pipe itself. Even in modern homes with current spec PVC, repeated lye exposure degrades the material at joints and fittings first, which is precisely where you do not want degradation to start, because joints are already your most vulnerable point. A plumber I spoke with who does camera inspections for a living put it plainly. He can tell, looking at a pipe interior, when a homeowner has been a heavy drain cleaner user. The scoring pattern is distinctive, the surface texture changes, and then he gives them an estimate for a repair that will cost them somewhere between $400 and $4,000, depending on where the damage is and how far it's progressed. The product that was supposed to solve a $20 problem created an $800 one. And nobody connects those two events because they're separated by years. In 1923, a chemist named Harry Drackett was looking for a way to sell more cleaning products to American households, and what he landed on was something genuinely clever. Not a better product, but a better fear. The Drackett company had been selling a furniture polish called Drackett's O-Cedar Oil, and they were looking to expand. The drain cleaner they developed, marketed under a name you'd recognize, wasn't technologically novel. Lye had been a household chemical for generations. What was novel was the packaging, the branding, and the specific anxiety it was designed to address. The marketing in those early decades was pointed directly at women running households, framing a slow drain as a hygiene failure, a social embarrassment, evidence of a poorly managed home. It worked extraordinarily well. By the 1950s, chemical drain cleaners had become a standard pantry item in American homes, the same way aspirin or dish soap had. The habit calcified, passed down through generations. Your parents probably had a bottle, their parents probably did too. And throughout that entire period, through the 1960s, the 1970s, the 1980s, the plumbing industry trade publications were quietly discussing the pipe damage issue. It wasn't secret information. It was in the professional literature. It just never made the jump to consumer awareness because there was no financial incentive for the chemical companies to amplify it, and the plumbing industry's concern was more focused on the professional liability angle than on consumer education. By the time PVC became the dominant pipe material in residential construction in the 1980s and 1990s, a new set of concerns entered the conversation. PVC and lye have a complicated relationship that depends heavily on the specific formulation, the age of the pipe, the temperature of the reaction, and how frequently it occurs. The chemical companies adjusted their formulas somewhat, added some corrosion inhibitors, tweaked the concentration levels. But the fundamental issue, that you are solving a soft blockage problem with a caustic chemical reaction that does not discriminate between what you want it to dissolve and what you want it to leave alone, that never changed. Picture your drain pipe like a metal straw that's been sitting in a cup of orange juice for 10 years. The outside looks fine, but the interior wall has been thinning the entire time. Now picture somebody periodically pouring something much more aggressive than orange juice down that straw, something that actively reacts with the material and doing it every few months for 20 years. The straw still looks fine from the outside. It passes casual inspection. And then one day, under pressure, it doesn't. The heat issue compounds everything. Sodium hydroxide reacting with water and organic material isn't just chemically caustic. It's exothermic, meaning the reaction generates substantial heat as a byproduct. In a well-ventilated, large-volume environment, that heat dissipates. In a 2-inch pipe under a sink, it concentrates. Old steel pipes expand and contract with temperature changes, and that cycling weakens joints over time. Cast iron, which is more brittle than steel, develops stress fractures. Even in fully modern PVC systems, repeated thermal stress at solvent-welded joints, which is how most modern pipes are connected, accelerates microseparation that won't be visible until it becomes a leak. There's another issue that almost nobody talks about, and this is the one that made me genuinely angry when I first understood it clearly. Chemical drain cleaners frequently don't fully clear the clog. They punch a hole through it, they dissolve enough of the blockage to restore partial flow, which you interpret as the problem being solved. But the material that's still coating the pipe walls, and still partially accumulated at the trap or the horizontal run, that's still there. And now it's been partially saponified, which changes its texture in a way that makes it slightly more adhesive, slightly more likely to catch the next thing that comes down. So you get a faster reclog, which leads to another bottle, which leads to another partial clearance. And the cycle sustains itself beautifully from a revenue standpoint. Professional plumbers have known this for decades. The chemical doesn't fix the underlying condition, the buildup pattern, the pipe angle, the particular soap and hair and grease combination that your specific household produces. It just temporarily interrupts it. A mechanical solution addresses the actual blockage. A chemical one, most of the time, just buys you a few weeks. So here's what a plumber does when they walk into their own house and the kitchen sink is draining slow. And it's not what they'll sell you at Home Depot. The first thing they reach for isn't a chemical at all. It's a drain snake, sometimes called a hand auger, which is a flexible metal cable that you feed into the drain until it hits the clog, then rotate to either break up the material or hook it and pull it out physically. A basic hand snake costs about $12. A decent one that will last you a decade costs $25. Plumbers keep a professional grade one on their truck that costs more, but the principle is identical. You are physically removing the obstruction rather than trying to dissolve it with a chemical reaction that doesn't know when to stop. The snake gets the clog out, not a hole through it. Out. You pull the cable back and there's evidence, actual physical material, on the end of the cable, that the problem has been addressed at its source. Drain opens up, water flows. No heat generated, no caustic reaction happening against your pipe walls. And depending on what was causing the slow drain, you also get diagnostic information. You can see whether it was primarily hair and soap, primarily grease, or something else entirely, which tells you whether your long-term approach should involve a drain screen, a different dish soap, or just more regular flushing with hot water. For kitchen drains, specifically, which tend to clog from grease accumulation rather than hair, boiling water is genuinely effective for maintenance, not for a fully blocked drain, but for keeping a slow drain from becoming a stopped one. A kettle of boiling water poured slowly down a kitchen drain once a week or once a month melts and mobilizes grease buildup without any chemical reaction whatsoever. Free. Zero pipe damage. Most plumbers do this routinely in their own kitchens as basic maintenance. It's not dramatic. It doesn't come in a bottle with bold graphics. It's just hot water, and it works, because grease melts. The solution that's quietly been sitting in agricultural supply stores and specialty cleaning aisles for decades is called an enzymatic drain treatment. And the reason you don't know about it is genuinely straightforward. It costs about $4, it works slowly, and it requires no emergency. Those are 3 characteristics that make something very difficult to market. Enzymatic drain treatments use live bacterial cultures and concentrated enzymes to biodegrade the organic material that builds up inside drain pipes. Hair, soap residue, grease, food particles, all of it is organic material, and all of it is exactly what these bacterial cultures are designed to break down. You pour it in, typically at night before you go to bed, so it has time to sit in the pipe undisturbed, and the bacteria get to work on the biofilm that's coating your pipe walls and gradually narrowing the channel. Here's the critical distinction from chemical cleaners. Enzymatic treatments don't generate heat. They don't produce a caustic reaction. They are, at the chemistry level, precisely targeted at organic material, because that's what bacteria evolved to process. They have no mechanism for degrading PVC, steel, cast iron, or copper. They cannot damage your pipes because they have no chemical pathway for doing so. The organisms involved literally cannot metabolize inorganic material. This is not a marketing claim. It's basic microbiology. The trade-off is time. Enzymatic treatment is maintenance, not emergency response. If your drain is fully blocked right now, tonight, with guests arriving in an hour, the bacterial culture working overnight is not your solution. The snake is your solution. But for the ongoing background accumulation that turns a clear drain into a slow drain and a slow drain into a blocked one, the enzymatic treatment, used monthly, interrupts that cycle without any of the pipe damage risk. You can find enzymatic drain treatments under several brand names. BioClean is one of the better known ones in professional circles. Green Gobbler makes an accessible retail version. But honestly, the generic agricultural supply versions work identically because the active mechanism is biological rather than proprietary chemistry. The bacteria don't care about branding. The mechanical approach costs nothing if you already own a wire coat hanger and about $12. If you want the tool plumbers actually keep in their truck, a wire coat hanger, straightened out with a small hook bent at one end, can clear a bathroom drain of the hair and soap scum clog that accounts for probably 70% of all residential drain calls. You don't need special training. You don't need chemicals. You put it in, you fish around until you feel resistance, you hook the material, and you pull it out. It takes 4 minutes, and it's done. For deeper clogs, past the trap, the hand snake handles it. Feed the cable in slowly, apply gentle rotational pressure when you hit resistance, and either break up the material mechanically or hook it and withdraw it. On the way out, you flush with hot water, not boiling, just hot tap water, to clear any loosened material. The whole process takes maybe 15 minutes the first time you do it, and 10 minutes every time after that, because you'll have learned the geometry of your specific drain. There's also the plunger, which gets underestimated constantly. A cup plunger, the standard type, doesn't work particularly well on sink drains, because it can't create adequate seal and pressure in the geometry of a sink basin. A flange plunger, which has an extended rubber flap that fits into the drain opening, works considerably better, $5. Strong, rhythmic plunging with a proper seal generates pressure waves in both directions, pushing material through and pulling it back, which dislodges clogs that a purely dissolving approach would only partially address. Plumbers plunge their own drains. This is not a beginner technique. This is the actual first-line professional technique. The full picture here is this. Chemical drain cleaners are a product that found a market by generating a recurring need. They're not particularly well equipped to address in a way that creates downstream damage invisible to the consumer until it becomes expensive. The alternatives, mechanical removal, enzymatic maintenance, basic hot water flushing, are cheaper, more effective at actually solving the underlying issue, and cause no collateral damage to the infrastructure you depend on. You're now holding information that took me 3 months of conversations with working plumbers, a deep dive into pipe material safety data sheets, and a fair amount of genuine frustration to piece together. The frustrating part isn't that the information was hidden. It's that it was always available, always sitting in trade publications. And material science documentation just never assembled into something a homeowner would encounter when standing in the cleaning products aisle trying to solve a problem. Go get a hand snake. $12. Keep it under the sink where you used to keep the chemicals. Next time the drain slows, use that first. For ongoing maintenance, and enzymatic treatment once a month handles the slow buildup that eventually becomes the emergency. And the boiling water trick for kitchen drains, just make it part of your weekly routine. It costs nothing, and it works. The next time you see that bold bottle on a store shelf, promising a clear drain in 30 minutes, you'll know what a plumber knows. It might clear the drain, temporarily, while starting a slow process on your pipes that won't come due for years. And when it does come due, nobody will connect the bill back to the bottle. If this kind of gap between professional knowledge and consumer knowledge matters to you, there's a lot more territory like this. The trades are full of it, techniques and products, and approaches that professionals use privately and that never quite make it into the mainstream conversation because there's no commercial incentive to put them there. Subscribe, and you'll catch the next time I pull one of these apart. And if you've had a plumber tell you something similar, or if you've already made the switch to mechanical methods and have results to share, drop it in the comments. Those conversations are always more useful than anything I could add alone.